Today's lesson is going to be a fairly quick lesson on friction. It's going to be fairly quick because we're going to be doing a lab during class, and you'll also have a lot of demos that we'll look at during class. So we're just going to go over the basic details fairly quickly, and then you'll investigate more during the lab and the demos. So the main thing to start with is that friction is a force. Okay, remember we talked about forces in the last unit, or the last section. That friction is a force. So a force that opposes motion between two objects that are in contact. Well, what causes this friction? See this picture here, you see the hills and valleys on one object are making contact with the hills and valleys of another object. So this picture here is just zoomed in version of these two boards or bricks or whatever those are. And you see those microscopic hills and valleys are kind of meshing together, making the friction. Think maybe like your desk. It feels smooth, but really if you could zoom in on your desk, you would see those microscopic hills and valleys. And when they intermesh on your textbook or your computer, whatever you have there, then we have some friction. The amount of friction is going to depend on lots of things. Some of those things include the force that pushes the objects together. We'll see that coming up, and also the roughness of the surfaces. You see a picture here like with the cleats for a football field or skates on the ice. Or maybe you think about the ice rink, and during, between periods, they come out with the Zamboni machine, and they spread a thin layer of water which fills in those hills and valleys, or fills in the valleys, I guess not the hills, but fills in the valleys, then freezes. So now it's a much smoother surface for you to skate on. Okay, so the roughness of the surfaces is definitely a big factor in friction. Okay, when you sand something smooth, you're getting rid of those hills and valleys so that you're going to have less friction. We're going to do a demo, kind of like the second part of this picture here in class, but we'll give you kind of a little preview with it here. So first thing it's asking you says, okay, I have a heavy book here, the yellow one, and then a lighter book here. Assuming everything else is the same, the roughness of the book and the table, all that stuff is the same, which one would have more friction? Well, the answer would be the heavier one, because the heaviness is intermeshing those hills and valleys more than in the lighter book. Well, now, okay, let's just take this book only now we're thinking of. What if I take the book and now I stand it on edge? Where's there more friction? When the book is lying flat like this, or when the book is on edge like this? So I'm not telling the answer now. I guess you could read it here, but we'll do this demo in class so you can really you can really see it in real life. Okay, so we have types of friction. Lots of words on this slide, but it's not too bad. There's basically two main types of friction: static, which you see up here, and then kinetic. And then kinetic has some subtypes. But static is friction on an object that is not moving. Okay, it's static. Think the name static. It's not moving. Static friction force will balance out the input force. Remember, we talked about balance forces last lesson. Once an object starts moving, the static friction is gone and replaced by kinetic friction. You'll see this in the lab. You'll also see this on the next page. But think about it with maybe the piano example down here or with the box here. So let's say with the piano. You start pushing that piano. You're pushing, pushing, pushing. The piano's not moving. That static friction is balancing out the force that you are applying to the piano. Then once that piano starts to move, hopefully it's on wheels to make it easier, it starts to roll, then it gets a lot easier, okay? Because the static friction has been replaced by one of these kinetic frictions, rolling probably. So static friction is that force that it takes to get a object moving that isn't moving. So once it's moving, then we replaced with kinetic. Okay, so kinetic is the friction of moving surfaces, or at least one of those moving. I put down three subtypes here that we'll talk about and we'll investigate. So sliding makes sense. Something's sliding against each other. You think about those hills and valleys. If they're sliding across each other, they're not having time to kind of intermesh or settle into each other. Rolling, using wheels or ball bearings, something like that. Again, we'll investigate these things during lab. And then fluid kinetic friction. That's going to be between an object and a fluid. So an example like this might be a rocket or a pod coming into the Earth's atmosphere. Or you think of a meteor that burns up. It doesn't technically burn up. We'll talk about that, but it burns up in the atmosphere. So we get that friction of an object that has a fluid going around it. So we'll talk about these different types. I said down here, compare the two types of friction after you do the lab. Again, not going to kind of go into it now because I want you to investigate it in the lab. Was an example of like starting and pushing a piano, or maybe if you're a football player, it's that kind of that tackling sled, where you're starting that tackling sled going, and once that tackling sled is sliding, you're sliding it. So I said you're going to do the lab first, and then on your notes you can kind of rank the different types of friction. So I'm not going to kind of give it away now. So here's a little bit more on the static friction I was talking about, because sometimes people have a hard time understanding where the static friction is. So I have a block sitting on a table. You see in the A thing here, it says there's no friction between the block and the table if you're not applying a force. Now for B, I am starting to apply a force. And you'll notice that the static friction exactly balances out the force applied. Okay, let's say I add a little bit more force. So I'm pushing a little bit more force. You see the purple arrow is now longer. That vector is now a little bit longer. So I applied more force. It says once it is greater than the force of static friction, the block is going to start to move, and that static friction has been replaced by kinetic friction. And you'll see the size of that force vector there. Okay, and again, we're going to measure this with spring scales to measure the different forces. And that static force is that force right before the object starts to move. And again, we'll measure that during class. And then the last thing is just, I want you to come up with some examples. I'll give one or two for these that you can write down, but then you can come up with more on your own. Friction can be good, friction can be bad. You can increase it, you can decrease it. There's lots of things about friction, lots of examples. So I said, just give us examples where friction is good, bad, and increase and decrease. So something like, where it's good. Well, maybe it's like starting a fire with sticks. Okay, you're rubbing them together, the friction causes heat, and you start a fire. Maybe it's something simple like standing. If I didn't have any friction, I wouldn't be able to stand. My feet would slide out from underneath me. I'd be laying flat on the ground. And then if there's a little bit of tilt on the floor, I'd be sliding down whichever way the floor goes. Or if I'm trying to turn in a car, if I didn't have friction, those wheels wouldn't be able to grip the road. So friction can definitely be good. Can it be bad? Oh yeah, sure. If you've ever fallen on a road or getting playing soccer and you're on the turf, you get turf burn or road burn, rug burn. You get that rubbing. That's certainly bad. In a car engine, the rubbing can overheat your car engine, break your car engine. So friction can definitely be bad too. Okay, give some examples of that. Of course, you could increase friction. Increase the roughness of the surfaces would be one way. So sand on an icy sidewalk, or putting a rug down on the chapel floor when it's wet so you don't slip and hurt yourself. So we can increase it. You could reduce friction. Maybe it's using oil in that car so that the pistons go up and down, they don't cause that heat. So lubricate an engine. Again, you think of that chapel floor, if you have water on it, it fills in those valleys and you slip and slide. And you see other examples here like banana peel and the bar here. So you can just write some examples down in your notes. So we're going to go over this during class with the lab and lots of demos. So we're going to make this, we're going to end it here to keep it nice and short. Thank you.